All right, Steve is here. He's a ACI Distinguished Staff and Code Advocacy Engineer, has his civil engineering degree from Lehigh University. He's a registered professional engineer, fellow of ACI, American Society of Civil Engineers, and Structural Engineers Institute. Steve has an extensive history in the advancement of technology and development of codes and standards related to all aspects of concrete and masonry design and construction. Steve's engagement in sustainability began in the late 1970s and include past chair and honorary member of the Sustainable Building Industry Council, drafting committee for the International Green Council Code, and active participation in related ACI committees, ASTM International Committee E60 on Sustainability, Green Building Initiative, Green Globes Consensus Committee, and many more. Okay, so let's welcome Steve. He's going to talk about code development, overview, and opportunities.
Great. Thank you, Szoke. So good afternoon, everybody. There's the one thing you're going to get out of this is it's complex. There is no easy solution. Building codes vary from jurisdiction to jurisdiction. The jurisdiction might be a country, it could be a province, it could be a state, it could be a municipality. They're all different. I'm going to focus on the International Building Code, which is, or the International Code Council codes, because those are the most popular in the state and also the basis for codes in other countries. I just had to pick something, either the Eurocodes or the ICC. So I'm most familiar with the ICC, so this is what you're going to get. So it's up to the authority having jurisdiction. How rapidly does this happen? Well, a model code is developed on a 3-year cycle. Then the jurisdictions take 3 to 6 years typically to adopt it. Some are longer, some might be quicker. But from the time that you have a reference standard introduced into a model code, it could be 9 years before it's enforced anywhere. So there is this huge time lag, which puts a lot of pressure on trying to advance things more rapidly. So in many ASTM, ACI standards, because of the complexity of the subject matter, they can take 10, 15 years to get developed. So it is a relatively slow process. The reason a lot of this is slow, though, is we need the assurances that everything's going to work right. So that's an important aspect of this. But this gives you an idea of the building code referencing ACI Standard 318. ACI Standard 318 is on a 6-year cycle. If the local jurisdiction is on a 3-year cycle, and like right now they might be looking at the adoption of the 2021, or they might be developing a 2021 building code for their jurisdiction, that would be based on a 2018 model code, which then references ACI 318.14. So that shows you the time lag that is out there. So when we're looking at the model codes, there's a model code where carbon neutrality of concrete or every other building material can fit and could fit quite well, and that is the International Green Construction Code. So this is, it's administered by the International Code Council. The technical content is actually developed using the ASHRAE process through an ASHRAE committee. It's ASHRAE 189. So this joint initiative. Again, the technical content is all handled at ASHRAE. ICC only focuses on the administrative content, or Chapter 1 of the code. What the code currently says is that you need to be reporting EPDs. It doesn't go into what level of performance needs to be required. Right now, we just don't have enough EPDs out there. So they're just trying to encourage more EPDs and allow the design professionals to make their judgment calls as to what products they select based on the available data. So it needs to be an industry-wide product declaration. A Type 3 declaration means it's verifiable and developed with an approved product category rules. So we have these environmental product declarations as well as other criteria such as, is the material regional, is it bio-based, recycled, but that's the level of extent that is covered when it comes to the material and the attributes of materials in sustainability. So we have these options. It does require third-party multi-use attribute declarations. So this information just needs to be generated and put out there. And the most important thing, as I just previously mentioned, is they're really looking at getting the reporting out there so that everybody understands what we're doing and we can get a track record of how things work. Now, the EPDs right now tend to be focused, at least for concrete, on these 7 categories. So this is what you'll see in a typical EPD for concrete if it's in the National Ready Mix Concrete Association's database. That doesn't mean these are the only things that matter. I was talking about the ASHRAE 189 standard. That's ASHRAE 189.1 for new buildings except 1 and 2 family dwellings. So, but then there's other criteria that might be required depending on the particular application. There's ASHRAE 189.3, that's for hospitals, and they're looking at some other possible considerations for what must be reported because of the potential for ionizing radiation, human toxicity, particulate matter. Those come into play if I'm dealing with a healthcare facility. So it depends on your facility and what can happen. Of these things, if it's a healthcare facility, one of the things that might come up for human toxicity related to concrete wouldn't be the concrete itself, but it could be any sealers or coatings or materials that you're putting onto the finished concrete. So the IGCC is permissive in Minnesota statewide, and all these other places there may be one or more local jurisdictions that have adopted the IGCC. So it has not been widely accepted across the U.S. So the New Building Institute, very aggressive organization trying to help get us to carbon neutrality, they brought in a code change proposal to the International Building Code. This was brought in the last cycle. The code change, if you go to the ICC website, you can find it as S17822, but it set specific limits on the CO2 content of mixed designs based on compressive strength. So this was a proposal. It got disapproved. It was part of a huge proposal that was covering glass and steel and wood, and industry opposed it because it was viewed as somewhat oversimplifying the whole concepts, and the building code officials voted to disapprove it because they didn't want it in the general building code. They felt it belonged more in the International Green Construction Code. So there was just this general conflict of, well, we want to make something happen and we wanted to make it happen everywhere, and the IGCC is only adopted in a few places, so it became cumbersome, to say the least. There is also the ICC 700, which is the National Green Building Standard. This is for 1 and 2 family dwellings. There is Chapter 6 on resource efficiencies. So they do address that. They do talk about things that you can do, but they're voluntary requirements when it comes to using concrete with 1 or more SEM. But again, it's moving in the right direction. It's a slow process because of all the complexities tied to this. Marin County in California took the NBI recommendations. So in Marin County, Marin County, California, there are currently these limits for CO2 content of your concrete mix designs. Washington State, NBI made this proposal to make modifications to the building code to comply with their section 1901.8.1, and it exempts small projects, it exempts precast shotcrete. So it's viewed by some that this might be upside down. The low-hanging fruit might be low dosage Portland cements for sidewalks, driveways, foundations, footers, small projects where there's a lot of them. Just like Mary was saying before, the concrete by itself doesn't look all that bad on her graph as far as the global warming potential. It's just that there's so much of it. So why not go after the larger volumes of concrete versus larger building types? So as we continue to look at this, this is pretty common as to what happens when they try to bring these specific requirements in. It tends to get backed off because of the comfort level of those writing the rules and regulations, so that it ends up being report EPDs. There's not enough EPDs out there for all the concrete. And these are just some examples of what is out there to show you the types and style. You know, sometimes it's a regulation, sometimes it's a code requirement, sometimes it's legislation. There's varying degrees of what is happening out there. The Carbon Leadership Forum says there's 230 plus entities worldwide that already have some sort of rule or regulation about carbon neutrality. So here, this is an example of stuff out of the General Assembly in Colorado, where it says to do a state project, you must have a current environmental product declaration. Again, that tends to be where we're at in most jurisdictions now. Similarly, Oregon. Then there's a database. The Oregon Ready Mix Concrete Association has a database for their producers, or a few of their producers, to help get the information out about the EPDs. So when we look at the recommendations from the federal agencies, the EPA was given the responsibility to come up with a recommendation for all the other agencies on how to measure and set limits on the carbon neutrality of building materials. So for concrete, they're saying 20% less embodied greenhouse gas emissions, or 40% less greenhouse gas emissions, or simply better than industry average. And that depends on what's available locally. So they give you these 3 options. If it's around, you must use it. If it's not, you fall into the next category. If not, you fall into the 3rd category, which is just a better than industry average. So it's either the top 20%, the top 40%, or just simply better than industry average. what's industry average? Is it industry average of those who have produced EPDs? Or is it really intended to be an industry average? The NRMCA database that's out there now, there's more than 7,000 ready-mix plants. There's over 2,000 ready-mix producing companies. So the NRMCA database has 60 companies reporting data. That's less than 3% of the industry that's reporting. There's 303 plants reporting, and that's only 4.5%. So what is that industry average? We're nowhere close to having anything that can be statistically demonstrated as being an industry average. So this gives you an idea of where the things are being reported, and it tends to look a lot like the most reporting is happening where there's some sort of rule, regulation, or code requirement. Oregon, Washington State, Colorado, California, that the reporting seems to be coming around as the jurisdictions are starting to require that EPDs be reported or go even further as far as the development of the provisions to reduce or to improve carbon neutrality. The General Services Administration, for all of their projects, basically requires the same thing that was adopted in Marin County. This is the table that's being promoted around the nation by the new building initiative. So again, the EPA set the framework and then directed both the FAA and the GSA to come up with a method of compliance. And this is all from the federal legislation, the Inflation Reduction Act. So ACI now has a newly formed committee, Low Carbon Concrete. They met for the first time at the last ACI convention. They are trying to put something together that can be referenceable in these other codes to try to move things forward. And again, it's complex. There's so much that should be dealt with or needs to be considered when we're dealing with this. Should it just be compressive strength? We get questions about that. There's cap limits already in 318 and 301, the design standard or the minimum code requirements and the specifications for structural concrete. If you have, for example, if you have a saltwater exposure where you have freeze thaw conditions, your SEMs can't go over 50%. It's just prohibited by the code right now. So other things need to happen. If we're going to take the approach of, well, what can we do to encourage carbonation to occur in the concrete once it's placed at the in situ reabsorption of CO2? Well, as the carbonation occurs, the protection for the reinforcing steel is going to diminish. So are you compromising durability of the rebar by having carbonation occurring in your concrete? There is no one simple solution, and it does get really complex, and we're trying to handle it with very simplified code provisions. So the American Society of Civil Engineers, through the Structural Engineering Institute, has a sustainability committee. They're also working on guidance documents for the structural engineers to make informed decisions. ASCE also has a standard practice for sustainable infrastructure. It's pretty benign, but ASCE 73 was just released this year. But also at ASCE, they are also creating a database of the overall impacts through life cycle assessment models of concrete well, all buildings, but there's a fair amount of concrete buildings in their database. So we have all these venues out there. As we develop a code, trying to figure out where the code gets adopted and how it's going to get adopted and who's going to champion it becomes a challenge for the industry. This is going to take a lot of boots on the ground, working with local jurisdictions to make things happen. So there's all these venues, there's federal legislation, presidential executive orders, gubernatorial executive orders, local ordinances. Things are happening everywhere on this subject, and a lot are still under development, but it is happening. So we need to be able to move forward. It would be nice to have everything based on some sort of national standard that is properly referenced. Get the ACI, get the work of ACI Committee 323 integrated into and aligned with the provisions going on with all these other standards organizations. So again, there's a fair amount of work. There's a lot of interest. There's also voluntary programs. There's LEAD, which is widely accepted. There's Green Globes by the Green Building Initiative. There's a fair amount of programs that are out there. There's private companies that are doing everything they can to try to make their facilities carbon neutral. And it's not just the material resources, but the operational energy and impacts as well. Our typical approach to getting ACI codes adopted and properly referenced is we have always looked primarily at the model codes or a national code, and then we would also look at, is there opportunities with standards that are being referenced. We might also be looking at state and local codes, but you can see that all the players currently involved in sustainability and carbon neutrality issues, it's huge. It's much bigger than the resources ACI already dedicates to this. So if anybody's interested in trying to champion something as ACI develops standards that are appropriate for adoption, we do have collaboration groups where people can participate. And before I get to this actual close, because we're here at new, I wanted to just mention something from the September 12th edition of Forbes magazine. They identified 4 challenges that the market and government forces have with accepting sustainability and carbon neutrality. The 4th thing they listed was transitioning supply chains, making sure that they can get the stuff that is out there that will provide a benefit. The 3rd thing they said was balancing short-term profits with long-term benefits. Makes sense because Forbes. Then the 2nd thing was aligning data and the metrics. And the number 1 thing was navigating greenwashing. So having something out there that prevents people from being exposed to claims that aren't accurate is something that's really important that needs to be done for all of this to work. So thank you.